I'm going to talk about climate impacts, and principally in the coastal zone. And here I am in Rhode Island. I'm going to talk briefly about coral reefs because Sheldon really likes coral reefs, but certainly the fisheries and the sea level rise issues are incredibly relevant to Rhode Island. So first of all, we think of fisheries, the biggest problem with fisheries is that we just eat too many fish and we rip out all the stocks and they're severely depleted and all the rest. But climate change makes all of those issues a lot worse and makes them a lot harder to fix. Seawater temperatures rising temperatures are moving stocks northward at an extraordinarily fast rate. Diseases of lobsters are moving north at a surprisingly fast rate and represents a major threat to the future of Maine fisheries. And ocean acidification is really taking a hit onto shellfish culture on the East Coast and also on the West. This little figure cartoon summarizes the complexity of the kinds of effects that climate change creates in the coastal zone. So the thermocline becomes much stronger, the hot water cools and floats on the surface. That makes it a lot harder for oxygen to get down to the bottom, and so we're seeing the oxygen minimum zone moving up shallower and shallower and shallower. That happened at the end of the Permian when the great mass extinction occurred that wiped out 90% of the species on Earth. Nobody's really expecting that now, but when you break down the connection between the deep sea and the surface waters, it has very serious consequences. Fish stocks go up or down as a function of moving in or out, and it's just incredibly interrelated and difficult. And every aspect of changing environment is, of course, dependent for the fish and the fisheries that are related to them. So here in the Northeast, red is a lot of red hake. And back in the 1960s and 70s, the great concentration of that important fishery species was down south of Massachusetts and New England in the middle Atlantic states. And progressively, over all that time, we've gotten to the point where the entire stock is in the Gulf of Maine, not where it used to be. And you can multiply that for cod and for haddock and for every important fishery species, which represents an enormous challenge to manage. And then this, I live in Maine half the year now on the Gulf of Maine, and this is just extraordinary. This color is lobster. Now think about the Gulf of Maine. 2 world wars were fought over the cod in the Gulf of Maine and on Georges Bank and further north, and they are gone. That's the biggest shifting baseline of all, of course. Lobsters were always abundant, so we're starting in 1950, and lobsters already by 1950, because the fish stocks were so depleted, had become the most important fishery in Maine. And look at how it's grown as a giant as everything else has more or less collapsed and become irrelevant. So at this stage, the only important fishery in the state of Maine is lobster. And we are utterly dependent on that. At the same time, the Gulf of Maine got 3 degrees centigrade warmer instantly one summer, 3 summers ago. That's 5 degrees Fahrenheit. And the only thing that has kept the shell wasting disease out of the Gulf of Maine, that by the way destroyed the entire lobster fishery of Long Island Sound and has already destroyed a lot of it in Massachusetts, the only thing keeping it out of Maine is cold water. So everybody knows that that warm water is going to hit Maine any year, the shell wasting disease is going to arrive, and 10,000 people will lose their jobs overnight because the fisheries industry is lobster and nothing else. And then finally, with regard to fisheries, shellfish, mariculture, and just the whole wonderful industry, which is very sustainable in other ways and is taking pressure off of the fin fisheries and all the rest, and is certainly one of the great hopes of fisheries for New England, as well as the Pacific Northwest, is really harmfully affected by ocean acidification. So This weird symbol is what's called the aragonite saturation index. And it has to be a good high number for oysters to be able to make their shells or corals to be able to make their skeletons. You can see this very strong nonlinear relationship in relation to pH. And in the graph below, you can see that shellfish production increases with that parameter, the saturation state. And what we're, of course, seeing in coastal waters is increased acidification, lower pH, and you can see what that does to larval development of the Pacific oyster, normal development on the left, deformed development on the right. And so in the state of Washington, for example, they're already spending tens of millions of dollars to raise the oyster spat in artificial conditions so that they can put them out and have a chance of surviving. And the same is going to be true here. Okay, moving to climate change and coral reefs. It's been in the news. This has been a really, really bad year for coral reefs. Seawater temperatures are intensifying, of course. The bleaching on the Great Barrier Reef this year was extraordinary. We'll look at that in a minute. It's not just warmer temperatures, it's also the acidification problem, and we now have experiments and field data showing that corals grow slower. It's much harder for them to make their skeletons with more acidic water. The good news in a very grim picture is that reefs that are protected from local stress, reefs that are protected from overfishing, reefs that are protected from too much coastal pollution are more resilient to climate change, either in that they resist the event in the first place, and also that they are more likely to recover. Places that are not locally protected are certainly doomed because of climate change. This is the history of temperature anomalies on the Great Barrier Reef for the past century, 1900 to the present. These are anomalies, how much the temperature rises above or below what the average of the previous century was. And what you can see since 1980 is these amazing high peaks. And there have been 3 major bleaching events on the Great Barrier Reef associated with each one of those major peaks. In 2016, really hot water approached the Barrier Reef, and there are zillions of these pictures, but this is a healthy staghorn coral reef. This is a dead reef 1 month later from the passing of the bleaching. And then boring organisms get into the skeleton, and within a year, this edifice, this dead edifice, will have collapsed into grains of sand, and it will be a flat bottom, and nobody will ever know that there was a coral reef there unless they had the privilege of seeing it when it was going. So this is what happened this year. The red zone, there was more than 80% death of corals within a month. In the middle, it was only 30%, and the lower part of the reef was much less. How come the middle part of the reef escaped so much damage? There was a merciful typhoon in the Philippines that stirred up the waters and increased upwelling of deeper, colder water onto the Barrier Reef. And if it had not been for that typhoon, the middle Barrier Reef would have suffered just as greatly as the northern Great Barrier Reef. Okay, now climate change and sea level rise, which is something which is a very, very, very big issue in Rhode Island. I'm going to pick on Florida because I had the misfortune of growing up there, and I have a personal relationship with the state. We know that sea level rise is going to be at least 1 meter by 2100. I'm being deliberately conservative. My personal belief is 6 feet. I don't see how we're going to avoid it, but there are some very bright people who think it's only going to be 3.5. Only 3.5 feet. Just think about that, what that means. And not only that, it's accelerating. It's a runaway process because of what we call positive feedbacks. And I'm going to show you a picture in a minute of 2 examples. The first thing relates to the melting of the ice in the Arctic. Think about it. 50 years ago, the Arctic Ocean in the winter was covered with white reflective sea ice. So most of the energy that was coming from the sun bounced off harmlessly back into the atmosphere. But as the water melts, The seawater is basically black compared to the white ice. It's a black body, it absorbs heat instead of reflecting heat. So what does that do? That makes the water warmer. What does that do? It makes more ice melt. What does that do? It makes more black water to absorb more heat. And on and on and on. Okay, methane release from the soils is the same sort of thing. Methane is a greenhouse gas which is 30 times stronger than carbon dioxide. And look at these pictures. So that's what the Arctic Ocean looks like today. You can see white and black. It's very vivid. And on the right, that's a pool of methane gas bubbling up out of the permafrost. The same thing is happening on the entire floor of the Arctic Ocean. It's a runaway process. Okay. Storm surge is the real killer. People say, oh, we're 3 feet above sea level, so we're great. It's only going to be 1.5 feet. Well, that's really sort of stupid, because when you get a 10-foot storm surge in a hurricane, like New England had in 1938, that means you're 8.5 feet underwater, right? And so storms of the century, we now know are going to happen every 3 to 20 years. Every 3 to 20 years, there will be a storm surge event in New England and in Florida and everywhere else. That's going to permanently drown the entire southern half to 2/3 of Florida and all of the south coast of Louisiana up to Baton Rouge. It's just going to do it. And this is Miami and Miami Beach. The OECD, not exactly a radical environmental organization, listed Miami as the most exposed city in the world to only 1.5 feet of sea level rise. There's 6 million people. There's $3.5 to $5 trillion in exposed assets. Houses that are drowned underwater are worth zero. And if you extend that north to St. Petersburg, you're talking about 10 million people, $10 trillion in exposed assets. I took this picture. I used to live somewhere there. That was back when people weren't as stupid as living out here. When I was 5 years old, a Category 2 almost drowned Miami Beach. Miami Beach is drowned by high tides now once a month. All of these islands are at sea level. In 1926, there was a Category 5 hurricane in Miami, the last time it ever happened. There were 80,000 people, that's all, living in Miami. 400 to 500 of them died. And those are the recorded deaths. It could have been as high as 1,000. That's 1,000 or 500 people out of 80,000. Now there's 6 million. What the hell does that mean for Miami? You know what it means. It means, oh, and it's dissolving away. That's the other thing, because Florida's limestone and it's honeycomb. And so literally, the houses, people are buried alive in sinkholes. It's pretty interesting. So, I mean, what is the future for Miami? It will be inundated, even if there isn't a hurricane. And in 50 years, the saltwater intrusion of the groundwater and everything else will make it totally unlivable. And yet, in spite of that, the city and the state are still encouraging massive building projects on landfill. It's illegal to mention climate change or sea level rise in any state building in the state of Florida. Insurance rates are going through the roof. This is going to be the changing factor. A 4-bedroom tract home with a federally backed mortgage is going to cost $30,000, $25,000 a year. For insurance, people are going to lose their homes because they're not going to be able to pay for it. There is no emergency evacuation plan for the 10 million people in the south of Florida. And you know, I've gone to meetings at the Naval War College where they talk about the permanent evacuation of the southern half to 2/3 of the state. And what are we going to do in the United States with 6 million climate refugees who nobody is going to want? So to summarize, and that's not because they're nice people, it's just, what are you going to do? Can you imagine Georgia doubling its population with 6 million Floridians? They don't like them very much anyway. I mean, it's hopeless, right? Okay, no, it's not, but it will be very bad. And we are great people and we will respond, but it will be very, very bad. So to summarize my cheerful talk, fisheries actually will adapt. You'll just eat different species of fish. And in fact, the sooner some of the subtropical species hit Maine, the better off we will be. We'll just adapt. And we'll get our lobster from Canada and our cod from Greenland. But at least they'll be there if we don't overfish them. Coral reefs are toast, as we know them are toast, but they will survive to a degree, and what we do can really make a difference. We are stuck with, I would say, 7 feet of sea level rise, but we could level it off if we switch to renewables in the next 20 years. If we do not switch to renewables in the next 20 years, we will have at least 40 feet of sea level rise that our grandchildren, or definitely our great-grandchildren, will have to live with. Think about that. And all of these issues, I'm really glad that we heard from the treasurer about subsidies, and I think Shelby mentioned it too, because none of this is going to happen if 2 things don't happen. We have to eliminate the fossil fuel subsidies, and we have to get out of the way of renewables, because right now we're still in the way of renewables. Thank you very much. Yeah. Are there any questions? I thought I'd cheer you up in the morning, but I'm actually very positive about the future because I think the signs are all really good. And I think we are actually waking up, and I think we are taking action. But you really got to keep in mind how bad it will be if we don't take action. Because if we don't take action, we're going to be a third world country. Because we are not equipped to deal. We're talking trillions of dollars here and trillions of dollars there. Those are big numbers. And normal economic rules and regulations break down with existential hits on that scale. And so that's what we're really facing. Yes, please.
It was a great talk, great presentation. In 20 years, can we really, as a global folks, can we make enough changes to make a big change?
Well, if I didn't believe it, I'd just go to Maine and drink, but there's a really great statistic. And I even checked it out, it's so good, because I knew somebody from Exxon would challenge me. The investment in the first quarter of 2016 in renewables was greater than the investment in all fossil fuels and nuclear. That is incredibly important, positive news. Why it isn't on the front page of the Wall Street Journal, well, I know the answer to that question, but it should be. Because what it tells you is that there are a lot of smart people with a lot of money who realize that the handwriting is on the wall. And so the way I like to say it is the smart money is in renewables and the stupid money is in fossil fuels. And I think young people in particular, smart business-oriented people are realizing this. And I think that's a really positive thing in a society like ours.
Jeremy, you might have heard about the violent role of reefs, coral reefs in the ocean, why they matter to people.
Yeah, well, you only give me 15 minutes, right? So coral reefs are like a really big deal for a lot of reasons. They deposit calcium carbonate. They take carbon dioxide out of the atmosphere. Seagrasses do that. Mangroves do that. All these ecosystems that we've done our best to destroy are critical with regard to black carbon and all this kind of stuff. I mean, they're just a very big deal. And then they're also, they protect the coast. I mean, and in a horrific tsunami that occurred from the earthquake in Indonesia, at Scripps, a guy at Scripps watched in real time. We can watch the Pacific Ocean at Scripps in real time. We can focus in, we can see a tsunami, and that guy watched, getting on the phone and desperately calling everybody to warn them that in 8 hours, a 50-foot wave or whatever the hell it was is going to hit you in Sri Lanka. Nowadays, there's a system that can do that. There's the equivalent of the red phone to actually get to the Navy and the Coast Guard and whatever to communicate that sort of information. But it was a devastating tidal wave, and the places that still had mangrove intact and had reefs in front of them, they It was rough, but they wrote it out, and almost nobody died. And the places where they cut down the mangroves, practically everybody died. I mean, so they have, you know, they're there for a reason in terms of how nature works. Coastal ecosystems build up behind these barriers that provide this protection, and they're vitally important. Nobody really knows how to value these things, you know, and I mean, what does it mean to say the coral reefs of the Caribbean are worth $500 billion? And so, I mean, nobody believes that number. It's a very big number. It's a hugely unimaginable number. The amount of protection which is provided to centers of population in the tropical world by the existence of coral reefs. And here in Rhode Island, it is exactly the same thing about salt marshes and seagrasses. They take the energy out of the waves. They are vitally important for coastal protection. Yes?
I'm trying to find some cheerful news here. There's been some anecdotal evidence in areas that have seen intense heat in coral reefs that in some places, and I look to the Virgin Islands National Park, where some species have shown some degree of tolerance, and those that are completely wiped out are actually beginning to repopulate some areas that were devastated by heat. Have you seen similar...
Well, I alluded to that very quickly because of rushing through, but I did a huge study of the status and trends of Caribbean coral reefs. It took 4 years. We had data from more than 35,000 studies, quantitative studies, done by hundreds of people. We put it all together and looked at it, and it is demonstrably true that places like Bermuda and Bonaire and the Flower Garden Banks until very recently that had real protections were either more resistant to total bleaching or have recovered more quickly. The flower gardens, the corals, it's just awful. The sludge from the detergent they used in the Deepwater Horizon has moved over onto the Flower Garden Banks. And there's been near 100% mortality of corals, which I hope institutes another lawsuit against BP, because they basically killed a coral reef indirectly, which is a national marine sanctuary and monument. And so, I mean, this is what we're all, I mean, you can either give up, like I said, or you can try and say, we have some evidence of adaptation. It's still pretty sketchy, but brilliant geneticists like Steve Palumbi are working on this, and he's seeing results that suggest that, you know, 100 million years ago in the Cretaceous, corals lived in an ocean that was on average 5 to 7 degrees centigrade hotter than it is today. But they had, you know, 1 million years to adapt. And what we're asking corals to do is adapt in 100 years rather than 1 million years. But evolutionists must happen faster than we thought. So, you know, I'm trying very hard not to be what I've been called in press, which is Dr. Doom. My wife and I used to be Drs. Doom and Gloom, and now we're Drs. Hope and Change. I mean, what else are you going to do? I mean, you know, otherwise it's just... But, I mean, look at this state. Look at the fact that fisheries have really been destroyed, but maybe they could come back. And look at the fact you're going to suffer from sea level rise, but you're really smart, and you have an amazing coastal zone management plan, and you're on top of it, and all the rest of it. You're going to weather it because you're smart. And the tragedy is in places like Florida that are being deliberately not smart to make a short-term buck. And those people,